Find a formal solution to the given initial boundary value problem. The partial derivative of u with respect to t equals the second partial derivative of u with respect to x for 0 is less than x is less than pi and t is greater than 0. U of 0 comma t equals u of pi comma t equals 0 for t greater than 0. U of x comma 0 equals x squared for 0 is less than x is less than pi. The solution is given in the text. U of x comma t equals the sum from n equals 1 to infinity of c sub n e to the negative beta times the quantity n pi divided by L all squared times t times sine of n pi x over L. And f of x equals the sum from n equals 1 to infinity of c sub n sine of n pi x over L. Therefore, we identify that beta is equal to 1, L is equal to pi, and f of x equals x squared. We need to get the coefficient from the sine series for x squared, for which the formula is x squared equals the sum from n equals 1 to infinity of c sub n sine of n pi x over L. L is equal to pi. The formula for the coefficient as taken from the textbook is c sub n equals 2 over pi times the integral from 0 to pi of x squared sine nx dx. Integrating and evaluating, we get that it equals 2 over pi times the quantity negative the quotient of pi squared cosine n pi and n plus 2 over n cubed times the quantity cosine n pi minus cosine 0. Simplifying, we get that it equals negative the quotient of pi squared times negative 1 squared and n plus the quotient of 2 times the quantity negative 1 to the n minus 1 and n cubed. Substituting the coefficient along with beta equals 1 and L equals pi into the formula for u of x comma t, we get that it equals the sum from n equals 1 to infinity of the quantity, the quotient of 2 pi times negative 1 to the n plus 1 and n, plus the quotient of 4 times the quantity negative 1 to the n minus 1 and pi n cubed, all times e to the negative n squared t times sine of nx.